Very good evening to everyone. Good evening to Jeffrey Adams sir and Krishna Reddy sir, Prasad Raju garu.
Thank you. Sir,
my esteemed colleagues and participants. So it's my privilege to introduce today's speaker, Dr. Jeffrey A. Adams, Principal ENGEO Incorporated, California, USA. Dr. Adams is a principal with San Rom, California-based ENGEO Incorporated. He received his BS, MS, and PhD degrees in civil engineering from University of Illinois at Chicago. Additionally, he received his MBA from the University of Washington. He is a licensed professional engineer in the state of California and a certified environmental manager in the state of Nevada. Dr. Adams provides development-related consulting services for a variety of public and private clients, including applications in geotechnical and environmental engineering. He has contributed to a wide range of remediation and development projects in high-density and low-density urban and suburban settings, redeveloped for a variety of uses. Dr. Adams has co-authored and contributed to several handbooks, textbooks, and instructional materials covering a range of topics, as well as a number of brownfield and environmental remediation related academic papers that have been presented worldwide and published in a diverse group of academic and professional journals. Dr. Adams lives in California, San Roman. So we are privileged to have you here, sir. Now I request Dr. Adams to take up the session.
Thank you, sir. Thank you for that introduction. And good evening to my distinguished colleagues in India and to others joining me from the United States as well as from around the world. I genuinely hope everyone is safe. We live in some interesting times right now, and I hope you're viewing this and everyone is safe and being safe. I was in India about 10 years ago, and for the 6th International Conference on Environmental Geotechnics in New Delhi, November of 2010, and really enjoyed my time there, and just enjoyed working with distinguished colleagues. Hopefully some of them are joining us today, and I think I speak for everybody that even though I'm calling in remotely today from my home, I look forward to the day where we can all be together and work together, and we can rekindle those friendships and the scholarship together. Oops. So we mentioned I'm calling from the other side of the planet today. I presume many of you are familiar with the United States and kind of the location of California in the United States, but just in case you're not, just a little bit about me, about where I'm calling from, and then a little bit about my company and our practice. Located in San Francisco, California. California is located on the west coast of the United States, bordering the Pacific Ocean. San Francisco is in the northern part of the state. And perhaps many of you know us for the city of San Francisco, but it's part of a greater region. Of course, the Golden Gate Bridge, I think many of you have seen, maybe seen it in person, surely you've seen it in pictures and other forms. But also the greater area, we're host to Silicon Valley and all the technological innovation that comes out of Silicon Valley. And many of you, again, since so many are associated with scholarship on this call and with universities, we are home to two very renowned universities, Stanford University, as well as the University of California, Berkeley. They're both in the region. It's interesting to practice civil engineering, geology, and other related sciences in the Bay Area. A little bit about the challenges that we face on a daily basis. Being located on the Pacific Ocean, the Ring of Fire, the area has a series of kind of northwest, southwest, just northwest, southeast trending hills and valleys, and is affected by many of the most renowned faults, dangerous faults, earthquake faults in the world. Many of you have heard of the San Andreas Fault. We have several others that do run through the Bay Area, the Hayward Fault, the Rogers Creek Fault, the Calaveras Fault. And as such, we're subject to a number of earthquakes and related issues every year, liquefaction, earthquake-induced landsliding, etc. Also, we have a number of geotechnical challenges that we face every day: expansive soils, the aforementioned liquefaction and landsliding. So it becomes an interesting time and an interesting place with the science to practice. Additionally, the area has been industrialized, heavily industrialized. The metropolitan area has about 9 million people, more or less. And not so much now, but in the recent past had a number of military facilities, lots of industry. And so from the geo-environmental and environmental perspective, we have a number of issues where we have to remediate. Additionally, the Bay Area, the weather here is conducive to agriculture. And as you move further east from the coast, we have a number of agricultural products that have been grown over the years, everything from cereal grains to fruits, to nuts, table crops, etc. And as such, as the city and the region continue to expand with commerce and with residences as people move in, we encroach on those agricultural areas, and we find a lot of legacy environmental impacts that we have to remediate. My company, ENGEO Incorporated, we were founded in 1971. We're based in San Ramon, California. We have approximately 300 employees, and really have grown over the years with our work practice. The 300 employees are spread across 2 continents. In addition to being based in the United States, we have offices in New Zealand, as well as in Australia. And something we're quite proud of over the years, really for the past 15 years, we've been recognized both locally in the markets that we serve, as well as nationally in the countries where we serve, consistently as the best place to work. Our office locations within the specific San Francisco Bay Area, we have 4 offices. We have 3 offices in Southern California, 1 in the Central Valley of California, which is considered the agricultural heartland of California, 1 along the Central Coast, that would be approximately equidistant between San Francisco and Los Angeles. We have 2 located in the eastern part of the state, as well as the adjacent state in Nevada, what we refer to as the Sierra Nevada region. It's one of our more prominent mountain ranges. We have a practice based in Seattle, Washington, which is about 1,200 kilometers north of San Francisco, as well as the practices that we have in New Zealand, Christchurch, Wellington, Auckland. New practices have emerged in our Australia offices, Sunshine Coast, the northeast portion of Australia, as well as South Australia, Adelaide. Finally, we have a new presence in Guam, which is a U.S. territory located in the Pacific Ocean. A little bit about us as far as what we value. We're very proud of a term that we coined, ENGEO-ness, which is how we interact with our colleagues, the positive and selfless commitment to the success of others. We serve our clients and we serve each other such that our client base is pleased beyond their expectations. And as one of the leaders in the company, we pride ourselves on making sure that our younger staff is served and they can grow and emerge and flourish into their practice of the profession. We try to live every day with integrity, both how we interact with our clients as well as with our colleagues. We adhere to a servant leadership model where we try to have a bottom-up approach where we serve the staff that we're entrusted with. And ultimately too, both because we feel it's good practice as well as we have to, we're strong about accountability, making sure that we're accountable to each other as well as to our clients and the various stakeholders that are involved in our project. Altogether makes it a wonderful place to work. Our core services, quickly, geotechnical really is what put us on the map. We have a full range of geotechnical practices. I'll outline a couple in a moment. Environmental and geo-environmental services. We focus heavily on engineering geology. I would make the argument that we probably have the best engineering geology practice on the West Coast. Significantly and emerging in the past decade is our growing earthquake engineering practice. We focus also on water resources and then construction, observation, and testing services for the projects that we design. Additional things that we can provide, we have fully certified laboratories that can provide a wide range of geotechnical and materials testing. We do a number of innovative instrumentation projects, both in situ and ex situ. We provide geographical information services technologies for the data that we have acquired in over 50 years of practice. We provide a number of stormwater related services to prevent contamination of downstream waters. We have a fleet of drone aircraft that we use to support construction, and design of projects and monitoring of projects. And we're also the unquestioned leader of a practice in California referred to as geologic hazard abatement districts, which is the mitigation and control, both through engineering controls, but also governmental and financial controls of development in adjacent areas where geologic hazards may be present. Project types: we serve commercial, industrial, education, the aforementioned geologic hazards. We provide services to healthcare facilities, hospitals, clinics. We help preserve historic structures throughout the United States, as well as abroad throughout the Pacific Rim. We provide support to either military construction or deconstruction as facilities may be relocated. We have a practice that provides to power and energy systems, both typical traditional fossil fuel based as well as emerging renewable energy sources. A wide array of public facilities and public safety facilities, fire stations, police stations, etc. Recreational facilities, everything from small parks to large stadiums for recreational sports teams. Residential support, single family homes, larger apartment buildings, and everything in between. Transportation support, roadways, highways, railways, aircraft and airports. Water treatment and conveyance systems. Many of the areas that we serve are typically arid, where water treatment and safe transport and conveyance are very important with limited resources. And we also provide flood control work. Geotechnical, we really do everything that one would be familiar with. Geotechnical work, subsurface characterization, laboratory testing, the geotechnical earthquake characterizations, foundation design, earthwork support, not only with design, but also during construction. And then given the fact that we have slope stability issues throughout the Bay Area and the areas where we practice, we do quite a bit of the design and mitigation of potential landsliding issues. Really anything that touches the ground. So really any type of civil works we're involved with: buildings, tanks, wharfs, shoreline improvements, levees, bridges, tunnels, pipelines, roadways, railways, and again, other large civil infrastructure that may not fall into those categories. Environmentally, I have the privilege of serving with some esteemed colleagues and help lead the practice. We do site characterization and assessments. We refer to them as phase 1, phase 2, phase 3. Phase 1 in the United States typically is kind of historic studies of what land uses may have been to identify potential contaminants that may be present at a site. Phase 2 is invasive testing of subsurface media such as groundwater, soil gas. We do the full characterization of these, and if we do identify contamination, we do full assessment and remediation consultation. Much of this can sometimes include groundwater monitoring, both the short-term grab sampling as long as longer-term projects to determine hydrogeology and related components. We do a lot of work with agricultural sites as they come into either continued productive agricultural work or for other uses. An emerging technology and an emerging issue for us is vapor intrusion of subsurface contamination, where following volatilization, those contaminants can enter into structures and pose health risks to occupants, either residential or commercial buildings. And finally, we do quite a bit of health risk assessments in support of these to determine if a site is impacted, what health risks are truly present, what are unacceptable, and how to remediate and mitigate these. Okay, so that's a little bit about me and my practice and how I focus, and shifting gears into the topics that I wanted to cover today. Professor Krishna Reddy is on the line. I was honored to work with him and Claudio Comaseye on a textbook that was issued last year regarding sustainable engineering. And I wanted to cover some of the topics, some of the initial topics that are presented in the textbook. And I show the textbook not necessarily as a sales pitch, but really just as a reference of how my presentation is organized today. And it mirrors the first few chapters of our book, kind of the first part of the book. Wanted to cover some of the definitions and some of the drivers, the key drivers that are associated with sustainable engineering and why we're worried about these, why we're concerned, and how these play in. Wanted to touch on some of the environmental concerns, the growing environmental concerns, either because they are emerging concerns or there are concerns of which have been around, but our awareness is continuing to grow. Talk a little bit about social, economic, and legal issues. Many of us focus on the environmental issues associated with sustainability, but there are other key as important factors related to the economics and the social. And we'll talk a little bit more about that. Focus a little bit on the availability and depletion of natural resources and how these play in to sustainable engineering, how we can protect those and utilize those resources better. And then talk a little bit about resiliency. This is also an emerging topic that goes hand in hand with sustainable engineering and is very important, as we consider civil infrastructure. Of course, we want to do right by the planet and preserve resources for future generations, but we also want to do stuff smartly. And as growing threats emerge around the world with respect to the planet in which we have to build our environment, how can we make our infrastructure more resilient to adapt to those challenges, both from a financial and a technical standpoint? So the first section I wanted to cover, the definitions and some of the drivers, and why some of these are important as well. Kind of in terms of our practice, from an academic standpoint, these are areas that are of interest and importance and growing importance to students, to faculty, to academia, and a lot of research is emerging. And to give you the industrial and the commerce perspective as somebody who practices on a daily basis, we are seeing these topics in our work around the world emerging more. Our New Zealand offices are achieving ISO 14001 certification, which focuses on the environmental systems that are in place to monitor both how we do our business, but also internally, but also externally, how we interact with our projects. And there's a growing expectation within New Zealand of having these systems in place and considering sustainability. It's becoming more important for work in which we're approaching for contracts. Our Australian operations are going for B Corp certification, which is a private corporation certification indicating that a company is pursuing green and sustainable practices. Again, for our Australian colleagues, this is important because there's an expectation and a growing expectation within the marketplace that companies are considering these and making these efforts within their business practices. For my colleagues in the United States, we've developed a sustainability committee that works with our colleagues around the world. And increasingly, as we go and team with companies to go after projects, both private and public projects, we're being asked to put together corporate responsibility plans, state what our sustainability plans are, consider sustainable alternatives. As we do more comprehensive study for larger projects, greenhouse gas emissions are being requested for our work, more focus on looking for ways to take a holistic look at our work. So slowly but surely, as Professor Krishna Reddy indicated yesterday, we can't make a claim that this is universal in everything we do, but we do certainly see an increase around the world of awareness and expectation of all the stakeholders for projects that sustainable technologies will be incorporated into the work. So some of the key drivers, what are some of the challenges we face? Kind of the big picture. Of course, we can all look around to our world and see these. These have been issues for a while and they continue to grow. And some of these are being exacerbated by interaction with other factors. And some are just emerging to the forefront. But we can all agree the consumption and depletion of natural resources, because our population is growing, we're consuming more. As the economy grows, we're consuming some more of these resources, and we're not doing so at a sustainable pace. And as such, as we deplete, we're getting to a point where we can't replenish, and we're going to be facing shortages for a number of natural resources. A lot of these human interactions and human activities are leading to water, soil, and air pollution. And we face this worldwide. Emerging markets as well as developed markets have to face these every day. Rapid population growth. I was born in 1972. The worldwide population at the time was about 4 billion. By the end of this decade, we'll approach 8 billion. So in my lifetime, the world population has doubled. And it continues to grow as such a space. And hopefully I'll live long enough to see it double again. But in any sort, our population is growing. And as such, they're putting more increased stressors on the environment, and with the need for natural resources to satisfy the economic needs for supporting people. Of course, with greater population and greater use of resources, we're increasing our waste generation. And how do we absorb this? How does the earth absorb it? Both solid waste as well as emissions that may enter into the atmosphere and other byproducts that may enter into our waterways. of growing concern, and we'll talk about this more throughout the presentation, are the effects of climate change. Certainly the Earth has been subjected to increasing and decreasing cycles of carbon dioxide within the atmosphere naturally since the beginning of time. But unequivocally, there's no doubt humans are adding to this. And as such, the anthropogenic contributions of carbon dioxide are having an effect on climate change. We are seeing this. Of course, we have to discern between weather, a day-to-day basis of weather versus general trends in climate. But it's coming, and we're seeing the effects of that. And all of us as practitioners in engineering and the sciences to better mankind have to be ready for this and have to have adaptable techniques with respect to infrastructure to address these. As we grow with our population, we deplete our resources, we're also affecting the ecosystems and the biodiversity that it supports. As humans sprawl out into formerly wildland areas, we're impacting those habitats and those ecosystems, and that's having a direct effect on species that may exist. As we sprawl as well, I mentioned it in California, we continue to encroach on agricultural lands, and we see this throughout the world, where as humans go to live and work, agricultural lands may be depleted. And finally, as important as the economic stressors are the social injustice and economic disparity. With growing wealth, as companies continue to develop their economies, we do see growing inequality among rich people and poor people. And this is a problem that needs to be addressed. How can we have it where people have access and more access to opportunities and the ability to contribute and benefit from this growth? And as such, there is social injustice. Sometimes you have a case of have and have-nots, regardless of a political system that may exist in a specific region or country. And the ability to address those social injustice issues are very important. And finally, with some of these things too, we're engineers, we're scientists. We like models, we like quantitative data, we like to be able to measure things. And certainly with many of these topics, as we'll get a little more into it, we have numerical models where we can do it relatively easily and effectively. But there are other issues too. And how do we measure some of the things that are semi-quantitative and do it meaningful? How do we measure social justice issues? How do we measure economic disparity? So, ultimately it's up to us to develop these systems as we go forward. So let's start with the basic question. What is sustainability? A very good definition, and one that's commonly cited, came from the United Nations, the Brundtland Commission that was formed in 1987. It's a development that meets the needs of the present without compromising the ability of future generations to meet their needs. The idea that we're here, let's use what we have to use, and the idea of ultimately, how can we make it better? How can we get to a position such that we leave the earth in a better place? We have to grow, our population is growing, we have to meet the needs of these, but we don't want to have a position where we compromise the needs of future generations. And the focus a lot of times is on the environmentalism, and that's a common theme in my presentation. We like to think of the environmental side of things, but there are other aspects, and we'll discuss those momentarily. But trying to achieve equity along the numerous dimensions of how do we consider present and future generations. How much consumption is enough, and how much is too much presently, where, how will it affect future generations? Many people have taken the tack that science will solve the problems now so the future generations can benefit. And that is held in many cases, but we have to be cognizant of this and continuously aware of making sure that, okay, if we do come up with solutions to existing problems, this will be helpful, and keeping an eye on how we can help those future generations. And finally, just looking for how do we align social causes and social benefits for people, as well as economic approaches and access. What I'm advocating for here, making the point of, is that it comes to just having access to participate in an economy and participate in the chance for growth and betterment. One of the benefits of civil engineering and the sciences is that we're all in these professions and these studies to better humanity. And how can we align that? How can we do our part so that all people are benefiting? And as we talk about it and we look to how do we measure these? How do we try to find that balance of protecting the environment, but also being mindful of the social and the economic aspects? Bring up the concept of the triple bottom line. As I mentioned, the environmental typically is in the front of mind, but the economic and social are very important. So we look for the balance, and this figure demonstrates that, the Venn diagram of trying to find the right balance and trying to be able to find solutions to projects and products that look to optimize the bottom line, that the environmental, that how do we balance the health among living systems, ecosystems, and goods and services, and how do we manage the waste? How can we be stewards of planet Earth? From an economic standpoint, we want to be able to induce the prosperity through the flow of capital and through the flow of money and through the flow of goods throughout the system, the economic system, so people benefit. So it's balancing that, the economics of it as well. And then finally, the social. It's the interaction between the people, our values, how we all interact, providing quality of life and increased quality of life for people, and doing it in an ethically and morally way. And it's striking the right balance. And as you can see in the figure, if we can hit all of these and we can balance these three triple bottom line parameters, that's when we have sustainability. You know, sometimes you get 2 out of 3 on projects, but if you can aspire to get 3 out of 3, you've truly hit sustainability. So that's sustainability, but what is sustainable engineering? Sustainable engineering is the development of engineered solutions to advance human life and humankind to maximize the benefits that can be provided by projects and products while minimizing the adverse effects to the environment, to the economy, and to society. Again, we're looking for the optimization of the triple bottom line. And in this case, we're looking for engineering solutions to products and projects to do so. We look for ways to foster these that can meet the needs of today's generations without compromising the ability of future generations to meet their needs. And then the American Society of Civil Engineers, I think, has a good definition as well that captures the essence of these concepts. Sustainability is the ability to meet human needs for natural resources, industrial products, energy, food, transportation, shelter, and effective waste management while conserving and enhancing environmental quality and the natural resource base for the future. When we talk about the United States and how we've emerged on this and how we've kind of been able to balance the environment, really the environmental movement in the United States came about in the early 1970s and throughout the 80s. That's when the awareness took place. Pre-1970, as demonstrated by the figure here, there really wasn't any type of compliance or awareness of this. There were a number of highly notable and highly visible environmental problems. Rivers were catching on fire with pollution. Smog in US cities, worldwide for that matter, were overtaken and affecting the populace. There was uncontrolled waste management with regards to solid waste. And because of this, the carrying capacity of the earth within the United States was noticeably being affected. And as such, there was a spurring and a movement, you know, first amongst the people, and then ultimately government caught up to that with various series of environmental regulations that were promulgated for society that focused on pollution control and compliance. Let's take care of things. Let's clean up what we've messed up. But then as time went on, a greater solution, kind of a higher and better use, if you will, where once the problems had been identified, it was really about preventing additional pollution going forward. Environmental management, taking care of the environment and making sure that waste products were not going to affect the environment. But then more highly and more forward thinking, how can you design civil infrastructure? How can you design consumer products and other related issues such that the designs were smart, that would minimize the chance for waste, would maximize chances for beneficial reuse of waste products. So we continue to evolve that. And that's the essence of sustainable engineering, is how can we design things that will have a good, useful life and will either allow the ability to continue with thoughtful repair and rehabilitation, or a thoughtful end of life cycle such that that beneficial reuse and those materials can be recaptured and repurposed into ongoing beneficial reuses for similar or differing products. A good example I wanted to talk about is a pharmaceutical medication that's very popular in the United States. Pfizer, the pharmaceutical company, has a very popular medication called Zoloft. Zoloft is a selective serotonin uptake inhibitor. It's an antidepressant that's used to treat a variety of psychological issues, such as depression, obsessive compulsive disorder, post-traumatic stress disorders, anxiety, and related maladies. And it's the United States is a very popular medication to be prescribed to people that are facing such disorders. It's one of the top 15 medications that are prescribed. And it's been around for almost 30 years and used quite frequently. And the The active ingredient is called sertraline, and it's now, Zoloft is a brand name of one company. Sertraline is now a generic drug, and it's used in other products as well. But the Pfizer company took a look at it and said, how can we make this a more sustainable product? And just through some thoughtful redesign of how they sourced their raw materials, how they handled their waste products, they were able to eliminate the use of, over the manufacture of the drug in an annual year, 140 metric tons of titanium tetrachloride, one of the raw materials that goes into the production of the medication, eliminated the annual use of 100 metric tons of sodium hydroxide, reduced the use of titanium dioxide by 440 metric tons per year, and eliminated the use of 150 metric tons of hydrochloric acid per year. So these are significant reductions just in the raw materials that are used to manufacture the drug. If you step back and you take a look at it, kind of the process, if I like to say, is, you know, peeling the onion. We can take a look at it from a life cycle analysis standpoint. The example that I shared with Pfizer really focuses just on the raw material of making the active ingredient that goes into the medicine. But you can take it further, much further, and think about everything that would go into a pharmaceutical product. There is everything from, as we discussed, the raw material fabrication, the transportation of those to a factory, the creation of the materials, the energy that goes into fabricating the medicine, the packaging of the medicine, the transport of the medicine into distribution centers, be it pharmacies, be it doctors' offices, whatever it may be. Then there are ancillary issues such as the sales and marketing approaches, how people interact and how these are prescribed. So there's a number of aspects that go into a medication where Pfizer, if they chose to do so, can look and further improve this and make the product more holistically sustainable. You know, where do you stop on this? If you take a look at the value chain of everything that goes into a pharmaceutical and everything that goes out of a pharmaceutical, there's a number of things to do. And the concept of life cycle assessment or analysis does this. The idea is to really kind of study everything that goes into a product to identify inputs and outputs and how additional sustainability can be garnered by this through design, thoughtful design, through utilization of materials, through use and operation, and then ultimately through the disposition of waste materials. Now, we're talking about pharmaceuticals. These are small products that can be handled very smartly. When we take a look at the bigger industry of civil engineering, infrastructure, and related sciences, there's huge opportunity for using this to look for more sustainable options and designs and uses and operation of civil infrastructure. I mean, think about raw materials. If we're talking about steel fabrication or concrete fabrication, the materials that go into it, how do you create the Portland cement? From where are you sourcing the aggregate materials? When you're talking about steel, we have to get the ore, we have to refine the ore or recycle existing scrap metal into usable products. And how can you design our systems using those such that they're used appropriately, that they can have smart technologies in for monitoring, perhaps self-healing technologies, and design the system in such a way that it has a beneficial, useful life over a period of time, and then those materials may be able to be recaptured and reused. So through the use of a life cycle assessment, we have the ability to take a look at how we approach these projects and look for real improvements in sustainability. And of course, everything in life is global. We all work together. The ability that I have speaking to all of you today from the other side of the planet is a demonstration of that. We're all interconnected. We all work together. And everything really that we do on a daily basis ultimately has a global consequence. It's very difficult to think about anything that we do from an engineering or a business or just a life perspective that doesn't have a global perspective to it, environmentally, economically, socially. And ultimately, we see how these play out in trade policies and regulations, how nations interact with each other to foster this beneficial exchange. And then some of the nuts and bolts, so to speak, behind how we interact. How do we stage and transport products, projects? How do we facilitate labor and capital to make our projects go forward? And how do we deal with the materials, the flows, the inflows, the outflows of our materials, either during fabrication, design, or operation, as well as the waste materials. These are global issues, and we have to think globally. Okay, so the second section that I want to speak about are the environmental concerns that we have to deal with on a daily basis. Climate change. Climate change is a big one. Obviously, we're seeing the effect from greenhouse gases from human uses and human consumption, both from natural sources as well as anthropogenic sources. Huge releases of carbon and related products and gases that have a similar effect to carbon dioxide to the atmosphere and affect the greenhouse gas. Now, of course, the greenhouse effect is very important to life on Earth. Because of the carbon dioxide in the atmosphere and other related gases, we're able to keep heat within the Earth. Without having a greenhouse effect on Earth and having those gases there, life would not exist on Earth. It would be an inhabitable planet. So we obviously need to have a greenhouse gas present so we can have a greenhouse effect, keeping temperatures moderate throughout the planet so that we can support life. But of course, through anthropogenic uses, we're exacerbating the presence of greenhouse gases. And it's not just carbon dioxide, and the table on the right-hand side demonstrates this. With a greenhouse gas potential, a global warming potential, other gases have an even more, a stronger effect on the greenhouse effect. If you assign a factor of 1 to carbon dioxide, methane, nitrous oxide, and then hydrofluorocarbons have an even greater effect. So it's not just the carbon dioxide, but all the gases that we create that are having a significant effect on how the planet operates. And again, of course, these are global issues. It can't be limited to one area because we all share ultimately the same atmosphere. So I mentioned Earth has the natural capacity, and there is obvious signs that there is natural variation in greenhouse gases over the ages. But again, because of the effects of human action since the start of the industrial age, nearly 200 years ago, we have noted deleterious effects due to global warming, such as increased temperatures. We're seeing ranges now that are similar between warm periods and the ice ages across the history of the planet. There were altered weather patterns. I'm going to talk about a couple of those in a moment, as well as rising seas that can affect ecosystems, can affect agriculture. There's a number of effects that we're having to take into consideration. Coastal cities due to inundation, the effect of droughts or flooding because of altered climate effects. The planet and the built environment are being affected by this. Wanted to share with you a couple real-time things that we're experiencing in the United States. And again, I do want to put a caveat here that I'm not implying that the two things I want to discuss here momentarily are due specifically or all to climate change. It's really just more of an example of a couple weather phenomena that we're experiencing in the United States literally today that have come about in the past couple of weeks that are due potentially to the effects of climate change, but are probably more related to natural weather phenomena. But the underlying issues of climate change and how the planet is warming and how altered weather patterns and rising seas can affect can affect humankind and our natural environment are important, are kind of eye-opening. The San Francisco Bay Area, perhaps maybe some of you are aware, we're experiencing some significant wildfires. We had a strange weather system that came in to our area. We had temperatures a couple of weeks back that exceeded 40 degrees Celsius, which is rather warm for this time of year. It's not unprecedented, but it was a warm pattern. And equally strange for this time of year, especially, we had a series of thunderstorms that came through. California has a wet, dry climate, but unlike kind of monsoonal type of climate like much of South Asia, we have an arid, wet, dry climate. We have moderate rain in the wintertime, and then we have dry summers. And as such, our vegetation is predominantly focused on grasses that dry out, scrub and shrubs that dry out, and our dry season, we tend not to get any rain really from April through October. And this cycle repeats. And as such, California is subjected to wildfires at the end of our summer into our fall. September, October is our typical fire season. And this has been a situation from the beginning of time for California and is part of our natural environment. But oddly, we had a series of thunderstorms that came through about 2 weeks ago. And this is something that happens every 20 years or so. And the thunderstorms came through with their lightning strikes that set numerous fires throughout the Bay Area and the greater state of California on fire. And so the map that I'm showing right now demonstrates the areas that are shaded in red are the locations and the extent of the burn areas that we're facing. And as you can see, geographically, these are large fires. These are encompassing a great deal of the area. Now, fortunately, these fires are located in wildland areas. They're conducive to burning because, there's not much human interaction there. The vegetation is such that it's always dry this time of year, and a combination of, as I mentioned, dry grasses, dry shrubs, dry trees, and not a lot of people live in these areas. The topography is such that also it's subject to deep canyons, steep hillsides, very difficult to battle fires in these locations. And once the fires start, they spread very quickly. Fortunately, all things considered, of the population of 9 million, there has been some minor loss of life, which is very tragic. There have been burning of structures, but they are located in relatively wild areas. But they're here and they're big. It's been estimated that the carbon emissions from these fires are going to approach about 62 million metric tons when all is said and done with the fires, which is roughly equal to the carbon emissions from the electrical generation throughout the state of California in an entire year. So we essentially have just doubled our emissions, if you want to think of it that way, from electric generation. And that's no small amount of electrical generation in California. California has 40 million people, and if it were considered separately from the United States as a standalone nation, it would have the fifth largest economy in the world. So these are significant carbon emissions that are taking place. And like I said, this is a weather phenomenon and a natural phenomenon that happens every year. But why do I put it in the scope of climate change? Well, there are some things that have come into play here that are probably being exacerbated by climate change. In the past several years, there have been droughts. Droughts do happen in California, but the feeling is that the droughts have become longer. They become more severe. There also has been some die-off of a number of trees, a lot of trees, large die-off of trees due to some emerging pathogens that some people have traced back to the potential for climate change. As the climate has changed, pathogens essentially have been activated, released, or promulgated that have affected trees and have created dry fuel to be consumed in these fires. Also, it's very rare in the Bay Area to be subjected to thunderstorms. We are adjacent to very cold ocean currents. It's one of the reasons why it's an arid area. And even though it was really a strange event that there just happened to be a tropical storm system that was blown into the area at the time of a heat wave, if oceans begin to warm and rise a little bit, it's not unreasonable to expect there will be an alteration in weather patterns as well. We may be subjected to more frequent thunderstorms. So this is not necessarily an event that was caused by climate change, but I think this event does give a picture of how climate change may promulgate. The second real-time example I wanted to share with you is the southern coast of the United States. Literally yesterday was struck by a very large hurricane. Hurricane Laura is migrating now through the midsection of the United States. It came ashore yesterday, kind of late day before evening, and is causing terrible destruction to property. Fortunately, the loss of life has been relatively minor. Again, tragic, but all things considered, how bad the storm was and how severe the storm is, people saw it coming. People took appropriate precautions for safety. But it's a very large, dangerous storm that came ashore. And some of you may be familiar with Hurricane Katrina, which hit about 15 years ago, hit in a similar location, the US state of Louisiana, specifically the city of New Orleans, and caused nearly unprecedented destruction to the city of New Orleans. Just because the city is a unique feature of it, it's been developed for a while. It actually sits below sea level in a basin, and when a hurricane came and the storm surges came, the levees have been overtopped and failed, and essentially filled up it like a lake, and it was just a terribly tragic situation. Fortunately, some of the infrastructure has been repaired in that area to deal with it, but Katrina was essentially viewed as almost a once-in-a-lifetime storm. A similar hurricane hit the area about 40 years prior. 1965, Hurricane Betsy hit the area, and then Hurricane Katrina hit the area 40 years later. Well, now Hurricane Laura hit the area 15 years later. The storm is stronger, both in terms of the sustained winds when it came ashore. Measured winds were approximately 240 kilometers per hour. And the storm surge, the wall of water that came ashore, was measured approximately 6.5 to 7 meters. These are areas that have low-lying areas that are occupied by humans, and they were just inundated by these storms. And the idea that comes up, it's a weather phenomenon that's not uncommon. The Gulf of Mexico is a very warm warm body of water. You know, it's subject to frequent hurricanes this time of year, but the feeling is as the oceans continue to warm up in the feeding waters, we're going to see more frequent storms. These are going to happen more often. We're going to have to be ready for them. So, you know, climate change is having a very real effect on civil infrastructure and how we are going to design it in the future. Some other topics that are similar from an environmental standpoint: desertification. 40% of the earth is dry or arid, and much of this is under significant impact from human activity. 70% of the land is under stress, either from degradation of agricultural or similar activities or outright desertification. And this land area is affecting directly 250 million people worldwide and nearly 1 billion people. 1/7 of the world population is at risk. And again, this comes from a number of things. This comes from overuse of areas, dry, arid areas, California included. Many parts of India, of course, have frequent irrigation. Irrigation can affect the land due to deposition of naturally occurring saline products within water after water evaporates. Degradation falls into 4 categories. You know, lightly degraded, the land is mildly eroded and salinized by the presence of salt and water. You still have about 70% of vegetation. And these categories get worse and worse, all the way to the point where you can get to an extreme where you just can't grow crops anymore. Restoration is just not feasible for use. So, you know, our human activity and the activity of the planet is starting to cause this and starting to manifest itself where the productive capabilities of lands are being directly impacted. Deforestation, you know, this is a very important visible topic around the world. Primarily, the removal of forests. Existing forests are caused or are imparted by either the conversion of agricultural land, the forest lands to agricultural land, or the harvesting of the wood products directly for use in construction materials, for building shelter, or for building garnering wood for fuel purposes, for cooking, etc. If you start to cut down the forest, especially if you do clear cut, you can have significant effects on the forest areas: loss of topsoil due to increased runoff, the absorption capacity of water. It becomes a vicious circle from the standpoint that you're not able to retain water, you lose moisture, the soils dry out, they become more susceptible to runoff, you have runoff, and it continues and continues. It's also important to point out that many of these forest areas, kind of counterintuitively, people see heavily forested, especially tropical rainforest, and think that they must be lush, the soils must be rich, but it's often counterproductive. Many of these areas, the soils are relatively nutrient poor just because of the precipitation cycles. Many of the nutrients are leached out, and the organic cycle within these forests are such that the nutrients are not replenished and available. So unfortunately, larger areas of forest have to be addressed and impacted to support a certain base level of agricultural production. And of course, as you cut down these forests, you're affecting very large areas of swaths of ecosystems, and have a significant effect on biodiversity, the flora and fauna that live within them. I'm going a step further on this. The disappearance of plant and animal species is going very quickly. It's been estimated that as we affect these ecosystems around the world, animal and plant species are disappearing at 50 to 100 times the rate of natural selection. So we're accelerating how these are becoming impacted, endangered, or extinct. Every year, it's estimated that 0.2 to 0.3% of species go extinct. That's a startling number when you put it over a time scale. If you multiply that by 100 years, you're talking about 20 to 30% of those species are being impacted. So a little bit adds up over a long period of time. You know, we have to think in terms, it's not even geologic time, it's just in human lifetimes. We're having significant effects on the environment. Many of our species are currently impacted. 1 out of 8 bird species, 1 out of 4 mammal species, 1 out of 4 coniferous forest species, 1 out of 3 amphibian species. So we have large families and species populations of both plants and animals that are being affected and are significantly facing effects. Human production has created a lot of great chemicals over the years that have created significant increases to human quality of life. Unfortunately, these chemicals have many unintended consequences in the environment. And one specific classification of chemical use is chlorofluorocarbons. These were very popular in the 1960s through the 1970s, but some breakthrough science at the time realized that the chlorofluorocarbons were affecting the ozone layer. That is invaluable for the protection of life. Without it, without the essential presence of the ozone layer, plant and animal life would perish on Earth. And the use of these chemicals started to erode because the chemical reactions would take place. The chlorofluorocarbons would interact with ozone within the atmosphere, the upper ozone. We're not talking about ground level ozone. We're talking about upper atmosphere ozone that protects plant and animal life from UV radiation. And as these interacted, the layer became thinner. The protective layer lost its efficacy or started to lose its efficacy. And UV has all kinds of effects. Can cause cancer, eye problems, systems on immunosuppression, directly can affect plants life in such that, especially for agricultural production, crop yields can be significantly affected. Aquatic systems can be affected. And of course, that has effect on the food chain for all living things. But there is a success story. These compounds were used quite heavily in the 1960s, 1970s. And then when the breakthrough science came along, realized that there were effects on the environment, there were international cooperative protocols that were put in place to outright ban these compounds. And uses since then have been severely curtailed. And the good news is it's coming back. Some of the ozone layer holes that have been detected over the southern hemisphere are starting to repair themselves. So the good news is, yes, if we come together in a moment of crisis, things can be solved. That's not the only air pollution issue we deal with. Volatile organic compounds can have significant health effects. Particulate matter, carbon monoxide, nitric oxides, sulfur oxides, heavy metals, all these are emitted through the burning of fuel for transportation, for power generation, natural or anthropogenic, and they have significant health effects. And again, some of these have been dealt with. Leaded fuels, the use of lead in gasoline, for many years by many countries has been significantly curtailed in the past 50 to 60 years when the connection was made between the presence of lead and its effect on the human brain. Lead has been linked to suppressing and affecting brain interaction in humans as dealing with the ability for impulse control. And studies have been shown to demonstrate that when lead has been curtailed in areas, that this function has, and this deleterious effect has been suppressed. We're not seeing it anymore. Some people have even drawn the conclusion that violent crimes have dropped in locations 20 years after the fact because this low-level brain damage that has been occurring in people has been stopped in future generations by the stopping of lead within gasolines. So when there are issues, things can be dealt with. Other compounds, industrial burning of coal and other similar fossil fuels, soot, sulfur compounds, water vapor is generated as well. Photochemical smog from the use of gasoline is an issue. So all these contribute and can be a problem. From the standpoint of acid rain, the use of similar compounds can have an effect on rainfall. The pH of rain will drop, the buffering capacity can be exceeded, and this can have a significant effect on the natural as well as the built environment, degrading structures, degrading architectural finishes, but also as importantly, if not more importantly, affecting aquatic habitats and the food chain that depends on it. Water usage and pollution, another environmental stressor that we face. There are limited freshwater sources. Of the water in the world, 97% of it exists in the ocean in a saline environment. Freshwater constitutes only 3% of water on the planet. Much of this is locked up in ice caps and glaciers, almost 70% of it. The remaining 30+% is tied up in groundwater, as well as in surface water. So ultimately, you have a very small percentage of accessible fresh water that is essential for life. And these resources are under impact and under effect from point source pollution, such as industrial facilities, wastewater treatments, as well as non-point sources, construction sites, agricultural runoff. And some of the effects that can be found within these waters, either due to wastewater, construction water, agricultural, chemicals, organic waste that run off from agricultural facilities, the presence of nutrients, nitrogen, phosphorus loading into surface waters can lead to algal blooms, hypoxia, eutrophication of surface waters. So the productive ability to support aquatic life can be significantly damaged. Climate change also has the insidious effect of rising sea levels affecting estuary environments such that backwaters become more brackish and more saline. And this is a big issue because much of human life exists on coastlines, and much fresh water is derived from rivers and estuaries that empty into coastal waters. As sea level rise, those water sources become more difficult to find because they become impacted with the water backing up and affecting the fresh estuary waters. So there can be a significant effect on the freshwater sources for humans going forward. Waste and disposals. From a solid waste standpoint, the numbers in the United States, the per capita generation in the United States per person per day was about 1.2 kilograms. This has increased, almost doubled, as measured in 2007 to 2.1. We're generating more waste through direct consumer, and then indirect consumption. Fortunately, there is an increased awareness about this and how we can recapture this, so we can address this through recycling, repurposing of these materials. There has been, obviously, over the past 50 to 100 years, a greater emphasis on sanitary disposal through the use of sanitary landfills, as well as trying to find ways to make these disposal facilities more productive, either through gas recapturing and determining ways that it sometimes can be used for cogeneration of power, as well as the reuse of lands once the landfills have been filled for recreational other purposes. So a beneficial repurposing of the lands. Of course, we have to be cognizant of emerging wastes. Electronic waste is becoming a big issue around the world as all the devices that we use and use at a higher pace are starting to enter in the environment, and how we can repurpose these materials. Medical wastes are a big issue. And then, of course, radioactive wastes. How do we deal with radioactive wastes going forward? Land contamination is a big environmental issue. All of the economic and human processes that we talk about do have an effect on our soil gas, our groundwater. Contamination comes from a variety of areas due to a variety of land uses. These can be transportation, industrial uses, agricultural, military, commercial. There's direct impacts, such things as underground tanks or above ground storage tanks that are used to store chemicals, hydrocarbons. Other industrial compounds can leak directly and affect the environment. Spills of chemicals, obviously, are an ongoing, continuing nuisance. And then indirect issues such as offspraying from agricultural compounds, byproduct deposition. We've talked a little bit about airborne lead, airly deposited lead. And fuels, fortunately, that has the use has been severely curtailed, but we do still find those materials in a number of places. So a wide variety of contaminants that we find on a daily basis: metals impacts, hydrocarbons, volatile organic compounds. They can be chlorinated, they can be hydrocarbon related. Semi-volatile organic compounds or polycyclic aromatic hydrocarbons are a growing presence. Pesticides, polychlorinated biphenyls, chemicals that were created that are so persistent in the environment because the molecules are so strong that they're used in their application 50, 75 years ago. We're still finding the chemicals, they just don't break down. Asbestos as well, naturally occurring or in building materials, is a problem. And so we as practitioners, engineers, and scientists have to find ways through the characterization and the screening of these and finding thoughtful, innovative ways to remediate. From a land use standpoint, this is having an effect on the environment. Dense developments, urban developments, lead to a greater concentration of waste and how we handle these. These can be human waste. These can be direct or indirect consumer wastes. If we concentrate people in a certain region, how do we handle that? How do we handle increase the carrying capacity of a certain area to handle the environmental impacts of human populations? On the other hand, sprawl can lead to polynucleic areas where you have interconnected regions or cities nearby. You have to find ways to intensively be able to service these. You have to have utilities and other infrastructure to connect these areas, be it wastewater, transportation, IT infrastructure. And the use of these networks can lead to greater greenhouse gas emissions. Also something that people are being increasingly aware of, especially in these COVID-19 days. that sprawl in human populations encroaching on previously wildland areas, there's a closer interaction of wildlife, and there's a thought that this can be setting the table for more future, more frequent pandemics, because we'll be coming more in contact with wildlife as well as the pathogens that may exist within those areas. So COVID-19, this may be, not an end all be all. This may be the first of many pathogens, pathogen-related pandemics that come down that humans have to deal with. Section 3, we talked a lot about the environmental stressors that we face, but social and economic kind of round out the what I like to call the three-legged stool. You have the economic, but you also have the social and the environmental. You have the social and the economic that you have to deal with. So some of these topics that are equally important, the concept of a society. What is a society? A good definition of a society: it's a system of functioning. A social system is functioning to reproduce the biological and cultural aspects of humankind within a territory. It's how we interact. It's how we reproduce. It's how we keep humankind going. And ultimately, we work together in a society because we're all trying to increase each other's utility. We're trying to increase the benefits through quality of life, growth, etc., so that we all, can benefit through our interactions. Societies also, typically there's some type of ownership of products or land or whatever that may be assigned to people. So it sets up a framework of how resources are allocated, as well as how we produce or reproduce those resources. And then the measurement within our social systems, the stocks, we refer to the physical, the living and the non-living, the humans, the biological compartments of infrastructure, livestock, materials creation, as well as land. Those are the stocks. And then the flows between that, the reproduction, migration, the actual doing of economic production. The inputs that go into it, the generation of energy, the generation of materials, as well as how we deal with those. So social systems are created so that we can manage the stocks, and the stocks can be utilized through flows to create a productive society. A couple things to consider too. When we talk about societies, we differentiate between more or faster developing societies or more developed societies and lesser or least developed societies. There are established economies and there are growing economies. But one thing I'd like to offer is that one of the benefits that growing economies or lesser developed economies have is that they can look to the mistakes that were made by bigger, more established, mature economies and avoid those mistakes with respect to economics, with respect to environmental issues. The good, the bad has emerged over the past 50, 100, 200, 300 years of societal development and economic production. And as other lesser developed countries around the world now enter into periods of growth, they can look at the mistakes that we learned, avoid those, and leapfrog those mistakes and directly go into faster, more efficient growth, to grow their societies. From a social standpoint, how do we measure these things? Again, we're scientists, we're engineers, we love to measure, we love models. It can be a little bit difficult to do this, but there are some ways to do this, and there are some semi-qualitative and semi-quantitative methods that we can do, where we can rate these, and you can measure and you can assign values on some type of base number or some type of relative contribution along a range of dimensions: social equity, social diversity, the cohesion, the interconnection between social classes, how quality of life can be improved, the degree and the maturity of the governance of the specific region, if it's democratic or totalitarian, and how that'll affect the populace, as well as kind of the maturity of how a society can deal with exogenous shocks to it, be it natural phenomena or social phenomena, how you can incorporate these and continue to survive and thrive as a society. Economic issues that we face. The physical economy, we tend to think in terms of the physical, the natural, the tangible, and how resources are used. Of course, you think back to our ancestors way back in the past, bartering between natural resources and actual physical goods. The money economy has replaced that. We can use the concept of national currencies of being able to exchange wealth and trade for goods and services. We also live in a world where there's virtual currencies now, like things like Bitcoin. So even the concept of money is starting to evolve. So, how this is captured and how we can trace this for economic growth is very, very important. And with respect to kind of sustainability through a market approach, why is sustainability well achieved through economic growth, and why does it play a good part? It's we have to face the fact that environmental damage has occurred because of humankind, regardless of the economic system or the social system that may be in place. Liberal democracies as well as totalitarian regimes have both had their hand in creating environmental catastrophe over the past 50 to 100 years. And my feeling has always been that if you can align the economic, we talk about optimizing the triple bottom line, and if you can provide economic benefit and incentive, people will act in a beneficial way. People want to be able to do good, but they want to do well at the same time. Look for ways to create wealth and create the benefit for many, many people, but do right by the environment, by society. The two economic concepts that I refer to are well into play here. John Maynard Keynes coined the idea of the animal spirits, and these are market participants who they want to do things that ultimately we're not programmed to always default to what is the most efficient or the best. What does the mathematical model say? We're creatures of action, and how can we align the creatures of action where people want to do something, and how can we have people that want to do something do right by the environment, do right by society, do right by the economy, and optimize the triple bottom line? The invisible hand is a concept that was coined by Adam Smith in The Wealth of Nations, over 200 years ago, that as people participate in the market and interact through commerce, there will be beneficial side effects that'll benefit everybody. That these beneficial side effects it'll act like a rising tide that'll lift all boats. So ultimately, it's these economic systems and finding incentives. If you can create the incentives within the economic system for people to achieve green and sustainable outcomes, ultimately you're going to have the greater benefit for all. And how do we do this? You try to capture, and how do you capture the value of these contributions for society? Well, there's a number of ways you can set it up in a traditional accounting framework. Some of the more simple things are just allocating costs. It's very easy to develop the costs associated with equipment, labor, supplies, structures, utility, the salvage value of materials at the end of life. But then there are more subtle things that we have to develop our costing systems for. The direct environmental costs, permits, waste treatment, response plans, those are easy to quantify as well. But then how do you assign costs such that you can incentivize people to act thoughtfully? What are the true costs of compliance, environmental compliance with regulations? Are there fines that are associated with it? If somebody does wrong by the environment, you have some type of compensation in place or a punitive system such that people will be fined because they didn't act appropriately. And then ultimately too, internal and external benefits. What are the benefits and how do you assign costs to this? The Zoloft example I gave earlier, that was very easy. By saving on raw materials, you're able to save money that is associated with making the product. You found a more efficient, cheaper way to make the same product. Those are direct, but then be it material savings or be it other things, there can be benefits to a company to ways that products or society develop their infrastructure and their projects of material savings, labor savings, but making things more optimistic and more optimal for use. And then finally too, if you can pursue sustainable outcomes, there's just the benefit of doing right, and being able to be acknowledged that finding holistic sustainable solutions is just the right thing to do, and being able to try to capture this, cost this, and provide those incentives can be very important. These can be incorporated into everything too. We take a look at the entire value chain of project or product development, the design, the implementation, the operation, the disposition, and trying to align these. And from an economic standpoint too, there's a number of traditional mathematical and financial models that can be used. The concepts of net present value, just straight payback methods, cost benefit analyses. There are a number of ways, traditional methods in accounting that can be applied to how we do this. And then ultimately too, trying to figure out what the time value of it is. There's a number of discount rates that can be applied. So the mathematical models are there that can be adopted for this. We look for that kind of interdisciplinary collaboration to do so. From a legal standpoint, every nation has its own legal framework, but from a bigger picture, some of the problems we've discussed really transcend boundaries. Greenhouse gas emissions and the effect on the greenhouse, the effects to the greenhouse gas layer, those are international. Air emissions know no boundaries. Watershed, in many cases, know no boundaries. Rivers and watercourses extend across many national boundaries. Acid precipitation, other weather patterns know no boundaries. Ozone depletion knows no boundaries. So a lot of the issues that we're facing, one specific nation's legal framework is not going to solve it. We have to look for collaboration between countries through treaties, through other pacts, either through the United Nations or between regional countries, so we can take on regional or truly international projects and problems together. Additionally, there's the interaction we've talked a lot today with respect to sustainability about how the generations interact, and how you enhance the standard of living and improve lives for people around the world at a given point in time. But then also, how do you balance this, and how do we focus now and try to create the ultimate and the optimized quality of life for people at a given time, while preserving it for future generations. So you have the tension between the existing people at one given time, T equals 0, as well as a range of T into the future. And then ultimately providing the motivation to do this. It's one thing to say that, yes, we should, as a specific generation in time, as well as future generations, how those can interact. How do we provide a motivation in place so that these generations are interacting and doing right by each other together, looking for ways that we can encourage and reward desired behavior to make more sustainable outcomes. With respect to the next section I want to talk to is some of the depletion of some of the resources that we have. We've touched on several of these, but something we need to be mindful of. When it comes to fossil fuels, coal is quite abundant, but coal usage is starting to drop. It's quite abundant, but it is the dirtiest of fossil fuels. And as such, many developed countries are starting to turn away from coal and look for other things. Oil, obviously, especially on the transportation aspects of it, because of its portability and its use in creating a number of other products. Oil is quite well, but the resources are becoming rapidly depleted. And it'll be interesting in the wake of COVID-19 as people rethink transportation patterns and perhaps, commute patterns with work and with life of, what's going to happen to the demand for oil. Natural gas, the third of the three traditional fossil fuels, is quite important. Its usage has gone up significantly in the past 25 to 30 years because of the perception that its emissions, it provides far fewer emissions compared to oil and coal. It is a cleaner burning fuel, no doubt. Its use has gone up, and the extraction of natural gas has increased significantly due to new drilling techniques, where previously uneconomic deposits were located. Now we're able to get them out easier and faster. There have been some innovations with respect to transport natural gas. So, of the three fossil fuels, we're seeing quite a bit of growth, both for transportation and power generation. But of course, as a fossil fuel, it has its limitations. So we have to look to other important things. Radioactive fuels. If you want, as I tell younger people with whom I work, if you want zero emissions, radioactive fuels work really, really well. It's emissions free. It by far is the most efficient means to generate power. Of course, we have nuclear waste that stems from this. Nuclear fuel and nuclear related materials in the hands of despotic regimes can be very difficult to world peace. It's quite the quandary. But it does present and reflect a significant portion of power generation around the world, and it is a clean fuel that can be used to address greenhouse gas emissions. Something to be mindful of, though, the waste that is created through the generation of nuclear material remains radioactive and dangerous for thousands of years. And one of the issues that we'll continually face is, what do we do with these materials? You have to find a way to keep people away from the storage of these materials for thousands of years. Languages evolve. global migration patterns evolve? How do you create a safe depository that will outlast civilizations? That is the question that we have with respect to the storage of radioactive waste until it becomes more benign. Mineral resources. We have the extraction of minerals, be it metallic or otherwise. These materials are used for a variety of materials for consumer goods, for projects, for infrastructure. You know, a good example is copper. The good news is copper is very easily recyclable. 80% of all the copper that's ever been mined is still in use and is still available for use, again, through recycling and through repurposing. However, our use of copper has been significantly increased in the past 100+ years. And we're getting to a point where our demand is going to outstrip supply in the not too distant future. And one of the problems is the easy stuff is already out of the ground, be it fossil fuels, be it copper or other similar products. Being able to get to these materials and pull them out of the ground is becoming increasingly difficult and is creating a lot of additional waste, both direct and indirect waste that we have to be aware of. Water resources. Water use has dramatically increased for a variety of reasons. And we're getting to a point where our reserves and our abilities, our uses of these materials are going to outstrip our sources in the not too distant future. Also worldwide, many people do not have access to basic water services, do not have access to basic sanitation. This is really a perfect storm for these for pathogens to be transmitted, for sicknesses to promulgate throughout populations. So ultimately, it's our water footprint. How can we reduce our water footprint and preserve these natural resources? When it comes to resource and depletion, our use of resources is increasing, but it's not always linear. Sometimes you get to a point where there is overconsumption, and you can get to a point where you can overshoot your resources. That there's a linear response to the use of resources, but ultimately you get to a point where there's a collapse, and this can be within flora and fauna or within our mineral resources. You can get to a point where there's overconsumption, misconsumption, and all of a sudden the ability to use it is collapsed. A great example would be fishing, overfishing of fish populations. When fishing increases on a linear basis, you can get to a point where you've reached a tipping point where the fish population is going to collapse and then that natural resource is gone, either forever or for a long period of time, not available for that current or immediately future generations. The concept of urban metabolism too, I mentioned it earlier. How do we measure the flow of energy and the flow of waste within an urban area? Typically, you can model this, and it is interesting though that even though you have a greater density, and the perception has always been that in urban areas you're going to have because of the density, you're going to have a more efficient use of materials. Consumption actually increases per capita, and the resulting waste generation increases per capita. Of course, we also have other issues with urban areas. Urban heat islands can affect the environment. And also when it comes to COVID, kind of the COVID perspective right now, there's some concern that having too many people in a specific location for this or future pandemics may increase our susceptibility to pandemics, that these pathogens can be transmitted quite easily. Finally, just wanted to touch on kind of the last part, disaster resiliency and how we deal with this. Resiliency with respect to infrastructure, and we'll keep it to infrastructure for the remaining time we have, is associated with the ability of a system to recover from a shock or a disturbance. And these can be ecological, these can be social, economic, or engineering related. And when we speak in terms of disaster resiliency, how does the built environment or engineered infrastructure, how can it sustain these impacts from the environment, from social unrest, from economic unrest, from engineering issues? How can it withstand and remain and be strong to be able to survive these shocks, both seen and unforeseen? A couple of the categories we want to talk about: sea level rise. This is a big issue. Depending on whatever category you want to use, over the remaining 80 years of the century, seas are going to be rising between 0.3 to 1 meter. 1.2 meters. This is going to have a significant effect of all coastal areas. All infrastructure on shorelines are going to be affected by this, and adjacent low-lying flat areas as well. natural resources such as water, such as wildlife populations, fish populations will have a significant effect. We've spoken a lot about how these weather patterns can be affected. So significant effects coming forward with respect to climate and how we have to design for it. We are collectively looking at this. There are several foundations that are looking for ways and looking to methods to increase resiliency within infrastructure through incentives and through research to try to find ways where our built environment can resist such issues. Ultimately, what we look to do, identify how climate change can affect these systems, identify the scope of the vulnerability of how these systems may be affected by natural disasters that will be coming over its design life, develop the procedure such that engineers can do detailed assessments, identify where the vulnerabilities may exist, and then have an adaptive management technique such that you can incorporate design as well as operational strategies so that you can respond to these foreseen or unforeseen or increasingly damaging effects. A good example very quickly would be a levee system. With a levee, it's having the ability to raise the levees, studying the length and the duration of the flows, figuring out what the dimensions of a levee may need to be, but then constantly study the flows that are adjacent to the levee that are being protected by the levee to figure out how and why you may need to develop and adapt that design in the future. Some of the challenges that we have to face, and this is my final slide, as all of these things emerge with respect to resiliency, be it climate or otherwise, our ability to predict is going to help determine what that range of adaptive management may be. What is the frequency? What is the scope of events that may occur in the future? Climate change certainly is a problem, but there are a number of other issues that we have to take into consideration. It can be sometimes difficult to quantify. There are some emerging techniques to do so. Professor Krishna Reddy spoke about Envision and LEAD yesterday. So there are some quantifiable techniques that are emerging to determine how this works. But ultimately, we need to find a consensus-based strategy and find a way to share best practices internationally so that we can design infrastructure that can be more resistant. Ultimately, too, COVID-19, I've mentioned it a couple times, but this will affect how we look at things. The world is under a significant economic depression right now. How do we get people back to work? How can we kickstart the economies of our world? There's some thought that the use of green energy systems can do this, bypass fossil fuels and build green. But also, how do we rethink cities? Are we going to go for density or are we going to go for sprawl? If you put people together, you may promulgate pathogens that are in the environment faster. People are entitled that a higher density will make quicker spread. But if you sprawl people out, you may open up human populations to a wider range of pathogens. So striking the right balance and all of the infrastructure that goes with that. With that, I'd like to thank everybody. It's been an absolute privilege and an honor to speak with all of you today. I know we're coming up against our time. My email is on the screen. If you have any questions, I'd love to take those via email. I'm also available on LinkedIn or Facebook. With that, I'd like to turn it over to our moderator.
Thank you, Dr. Adams. Shall we take some questions, sir?
I would be honored to. Yes.
Yeah, Krishna Reddy sir, would you like to add something?
Yeah, just want to make one comment. Dr. Adams, you did an excellent job. Superb job in presenting, all broad aspects of sustainable engineering. I hope, your presentation content is going to be extremely useful for all the attendees. And I know, one of the things is, you covered a lot of topics that really emphasizes the need for looking at sustainability holistically, not just, sometimes we get carried away with a small thing that we are doing, but in a big picture, we need to have a big picture. Whatever we're doing, that's fine, but we need to have a big picture of what sustainability is. So I think you provided all the drivers and what are the reasons why we need to be worried about sustainability and what are the things that we need to worry about. I know this your lecture is being recorded, so hopefully attendees can replay it and understand in detail, the things that you've talked about. I hope all the attendees make a full use of Dr. Adams' presentation in terms of enriching their knowledge, or even in terms of their teaching, or in terms of doing research. I also want to mention that Dr. Adams was a co-author of is a co-author of our book Sustainable Engineering. As I mentioned before, you could use that as a textbook to teach sustainable engineering class, or you can read it for your own information. The things that Dr. Adams talked about, they are all in the textbook. First 5 chapters of the textbook, he pretty much covered everything in detail. So I really recommend you to read the textbook and replay Dr. Adams' presentation as many times as you can to get all the nitty-bitty details about what he is talking about. Again, I want to thank Dr. Adams. Today is his work day. He took time off from his work and spent almost 2 hours of his valuable time with us. So we should all be grateful for his time and effort he made in giving this presentation. So again, on behalf of all the organizers and at least participants, I want to thank you, Jeff, for your work.
Thank you.
Okay,
Thank you, Mr. Reddy.
Sure.
Yeah, shall I go ahead with the questions, sir?
Yeah. Yes, please. How's about, would you read them and I can answer them, or what?
Yeah,
How do you prefer?
I will read out, sir. Sustainability through market approach and accounting approaches has been explained. There is one important approach that I believe is educating people approach about the sustainability can bring more changes. What is your opinion about it?
I agree. I think education is very important here. And as I mentioned, it's the education, and I think the incentives are very important. When people can see what the big picture is, how sustainability will, sustainable outcomes, how they will benefit and affect and improve quality of life, not only for the individual, but also for the group as a whole, I think it's very important. And I think if you can align the incentives with it, such that, people that are participating in the market want to do so. And again, it could be through a number of things. It could be through, breaks in taxes. It could be through, government grants. It could be through a number of things. Ultimately, if you can reward, or you can at least direct people to do that, and they're educated about the benefits that'll be derived, I think you're going to come up with those outcomes.
Yes. Mr. Anand Reddy, you can ask question. Unmute yourself.
Thank you, sir. Good evening, sir. Good
Go
evening,
ahead.
sir.
Go ahead.
Good
Switch
evening.
on
Good
your
evening.
video, please. Yeah, go ahead.
Good evening, all.
Good evening, sir.
Jeff, yeah, good evening. My question is, like in your last slides, as you have highlighted that the radioactive minerals, the materials are have zero emissions. So I didn't get that part. Can you highlight that?
Sure. As we look for power generation, if you look at fossil fuels, of course, we have traditional air emissions. If you have a nuclear reactor that's used for power generation, ultimately you have zero air emissions that'll come out. So if we're looking to reduce greenhouse gases, nuclear power generation is a very efficient, very good means to do that, to reduce air emissions. Of course, we're going to have significant waste from the spent nuclear material. So it creates another problem. It's not an air emissions issue. It becomes a significant solid waste issue, an unprecedented solid waste. So by all means, you've eliminated one problem, you've created an unprecedented problem in another way. So it's always trying to strike the right balance. It becomes, what is the problem? How do you want to solve it? And then how do you deal with the new problem that is presented?
Yes. Actually, again, the radioactive minerals, it's again a solid waste which is generated.
Yes.
Yes.
Yes. So I certainly didn't want to imply that there wasn't a waste. I implied that there was no air emissions. But yes, of
Yes,
course,
yes.
the solid waste is highly dangerous and persistent. And that becomes one of the issues that we have to face. You create materials that are dangerous for thousands of years. That will last
Yes.
past many civilizations. How do you make people in the distant future aware that those materials are dangerous? That's also a dilemma.
Remediation of that part, it's also a very, it becomes a critical part again, a complex
Yes.
thing, right?
Yes, absolutely.
Yeah. So this book covers any of that, like remediation methodologies for radioactive materials?
Well, we talk about it. We talk about some strategies of kind of the bigger picture strategies. We don't get specifically into the engineering approaches of how to, so we don't talk about various innovative remediation technologies themselves. We'll mention them, but we don't talk necessarily about the details of them. So there are books that will talk about in significant detail about how to remediate things. We'll talk about the approaches that may be used though.
So as you have highlighted in your in your office, you also give the what do you say, remediation technologies for radioactive materials. So if there is any radiation, what kind of remediation technology is applied? Can you highlight or?
Yeah, in my practice, we've had some situations where we've had very low level
Okay.
remediation.
Like what kind of radiation was it, and what was the solution for that?
Yeah. We've encountered a couple times some medical waste where it's been
Okay.
used in nuclear medicine.
Yes.
And certainly nothing having to do with power generation, but medical waste and other similar products. And in our case, it was a matter of identifying it and then encapsulating it. We didn't do a specific biochemical or chemical or physical treatment of it. It was just it became just kind of of that approach.
So these conventional binders like cement or any binders where we say like calcium sulfate, calcium aluminate cement, which is having like higher absorption capacity. Will that work, or we need to have something advanced materials or binders?
Yeah, I have to confess it's not my specific area of expertise. I would imagine if it were lower level, it could perhaps work. Undoubtedly there were many people on this call that probably have a far better, understanding or a far better expertise in this area. So I would defer to them.
Thank you. Thank you.
Thank you, Anand.
Yeah, got it. Thank you. Thank you.
Thank you.
Yeah. Shall we conclude, sir? No other questions? Adam, sir.
Yes, sir. Yes, sir.
I thank Dr. Adams for his valuable insights. So he has elaborated very nicely about NGO and its operations, services, and projects across the world, and his book, along with Professor Krishna Reddy and Kamselli, on sustainability. So it's a very good book. So we have included your book, sir, as textbook. So then coming to his lecture is concerned, so he has elaborated about sustainability, imbibing into engineering projects and in general marketing other products. So in 5 sections. In his first section of his lecture, definitions and key drivers of sustainability, challenges the world is facing today with regard to various problems, then triple bottom line of sustainability everybody should adapt. Then case studies, so like Joloft, and he discussed about life cycle analysis of with the help of peeling the onion. Then in his second section of his lecture, he has completely elaborated on environmental concerns, then climate change issues, then he explained with the help of wildfires in California, then hurricanes, Hurricane Laura, then desertification, deforestation, then habitat reduction and destruction, Then he has focused on air pollution, water pollution, and waste disposal mechanisms, then land contamination and its use. Then in section 3 of his lecture, he elaborated on social, economical, and legal issues. Then he discussed about societal systems and how it is going to influence the society. Then developed and developing societies and the social sustainability indicators that are to be considered when you try to estimate the sustainability, and measure the sustainability. Then economic issues, sustainability through a market approach, and accounting issues for sustainability. So even with that also we can reduce the natural resource consumption. Then coming to the legal issues, so he has spoken about very clearly what are the legal implications that are to be elaborately discussed and before taking up anything. So that you can achieve the sustainability. Then section 4 of his lecture focuses on fuel resources, mineral resources, source depletion and overshooting of the sources, then urban metabolism. So these are very important. So what is the source available, and then what is the demand you have? So how you need to conserve these resources and then give to the future generations. Then section 5 of his lecture, disaster resilience, which is very, very important and a need of the day and a feature of the day. So we cannot stop the natural disasters, but we can mitigate the disasters. So by imbibing sustainability concepts. So that's what he has completely elaborated. Resilient infrastructure, that is the duty and responsibility of all civil engineers. Then resiliency challenges. What are the challenges before the engineering community? So to make all the infrastructure as resilient, disaster resilient. So everywhere, every day, every minute, we are hearing that this disaster and that disaster, which is not in our hands. So only we can mitigate the damage that is going to be caused by the natural disaster. We cannot stop the natural disaster. So he has elaborated very nicely. So complete holistic understanding of sustainable concepts. So applied to various concepts, various applications he has elaborated. I hope so. This has given an holistic idea about sustainability. So I thank Dr. Adams for his valuable lecture, and he spared his valuable time. Thank you, Dr. Adams. We will be in touch with you. So we will be asking your help. And so in running the program also, we are offering one program, minor program, honors program in green technology and sustainable engineering as part of undergraduate program. So for all branches of engineering, so we may approach you for certain things. So I need your help in designing the courses, also specific courses, especially technical design of infrastructure like that. So thank you very much, sir.
Thank you, sir. And thank you to everyone. Thank you for taking your time. It's an honor to me that all of you took time to join us tonight. And I wish all of you a very pleasant, happy evening. Thank you.
Thank you. Thank you, Adam, sir.
Thank you, sir.
Thank you all the participants. So tomorrow we will have again at 11 o'clock, the third day session will start. 11 to 12 and 12 to 1. We have 2 sessions. Tomorrow is the last day of faculty development program. So thank you very much, sir.
Thank you.
Good night.
Thank you. Good night, sir.
Good day, sir, for you. Thank you.
Good day. Thank you, sir.